Hi, in this section, we're gonna talk about superposition and source transformation. So first, we're gonna look at the superposition, give some examples. Later, we're gonna look at the source transformation, so give some examples. So first, superposition. Superposition can be defined like this. The voltage across any element in the linear circuit is the algebraic sum of the voltage across that element due to each independent source acting alone. Basically, if you have multiple sources, you can see affect each one individual to any element, then you can combine them as an algebraic sum uh, together to find the total uh, voltage source or current through the elements. So these steps, how we're gonna do this one here. Steps number one, we're gonna turn off all the independent sources except one source. Then we will find the output due to that active source, or we're gonna find the current due to that active source. We're gonna repeat this one for each of the other independent sources. Then we're gonna find the total contribution of by algebraic addition of those source effect. What is the disadvantage of this one? Basically, it may take more time. So need to analyze it for each independent circuit individually. So it may take a long time. What are the advantages? Basically, we can reduce the complex circuit for a simple circuit. What we're gonna do? Because we're gonna replace the voltage sources as a short circuit and current source as an open circuit, except one of the source alone there. Let me give an example here. What does that mean? Um, we have a circuit here as given, this one here. We're gonna say we're gonna solve this one by using actually a superposition theorem. We can solve individual, but let's see how we can solve this one with superposition. So when we look at here, we have two sources. One is 12 volts, the other one is 0.3 ampere. So we're gonna leave one source, then find out the voltage right there. The we're gonna make the other one is out. Second case, we're gonna leave the other one, then turn out the other one. Then we're gonna find the voltage source right there again. Then we're gonna combine them. That's why I call them actually V1 and V2 right there. V will be equal right there. So first, let's take out a current source. If it is a current source, when you take out the current source, we're gonna leave that point is open. Okay, open circuit. So that's why we take this one out, open circuit. So we're gonna have circuit like this here. Okay, so voltage source is right there, 12 volts. If you're gonna find the V1, this is looks like actually voltage. What is voltage? Um, so this will be actually voltage division. So if you wanna find V1, easily we can find V1 as 40 ohms divided by 40 plus 80 times 12, which give you 4 volts right there, V1. So using one source, we find the V1 right there. Second case, we're gonna take out the voltage source. We're gonna put the current source back again. When you take the voltage source out, we're gonna make short circuit. So our circuit comes like this here. If you look at the circuit here, to find the V1 here, we can find I2 first easily, because this is current division. In current division, we put this one on the numerator, then combine right there. So I2 will be equal 80 divided by 40 plus 80 times 0.3 ampere. So this will give you 0.2 ampere. So V2 easily we can say, oh, 0.2 times 40 give you 8 volts. So find the V will be equal V1 plus V2. That will be equal 4 plus 8. That is equal 12 volts. So this is the solution of this problem here. We give you one exercise. We're gonna try to do this one in the class. I would like you guys work on this one before the class so we can try to do together, see how we guys doing. Okay, let me give one example here with the dependent sources too also. In this case here, when we look at here, we're gonna find I0. I0 is right here. If you guys see it, I0 is right there. In this one here using superposition. So first we're gonna leave one source, independent source, take the other one out. So we have two sources. So let's take this one out first. That's why we're gonna make voltage source current short. That's why we have here again. In this one, if we wanna find the I0 here, I call this one I0 prime. Then second source case, we're gonna use I0 double prime right there. Okay. I look at this one here. You can write node equation if you want. You can write the mesh, but we have a voltage source right there. It might be difficult to write voltage KCL. Let's do a KVL or mesh equations. So first of all, first one here, I1, because of current source right there, I1 is equal here 40 milliampere. What is I prime, small I0 prime here? I0 prime should be equal I1 minus I3. Okay, so let's write the mesh I2 and mesh I3 right there. Let me change the color here. I know we wrote right there, but I'm gonna write with you guys again one more time here. So mesh, so I have 100. Okay, let me see. First of all here, let me delete this one here. Okay, and let me get this one here. So I1 effective mesh I2 is only 200. So negative 200 I1 plus 100 plus 200 plus 300, 600 plus, that's it, I believe. So 600 I2 negative, what is negative right there? We're gonna have it 100 I3 will be equal or negative 200 I0 prime, 200 I0 prime right there equals 0. So that's why we have this one here. This is equation number 1. Equation number 2, we're gonna write from this one here. I can say here negative 500 I1 negative 100, this one here, 100 I2 plus I3 will be equal 500 plus 100 plus 400 was gonna 1000 I3 and plus 200 I0 prime will be equal 0 here. So basically we have two equations, two unknowns, because we know I1 and we need to find I2 and I3. Actually we need to find I3 for our case to find I0 prime. So we can substitute I prime to right there, and also same way to right here too. We can substitute I1 value because we know I1 value. Let me write them as separate equation before going to the next slide. Do I have any room right? I can write it. Maybe right there I can write with you guys. So first equation here, it's gonna be negative 200 times I1 is 0.04 plus 600 I2 minus 100 I3 minus 200, and here I1 minus I3 will be equal 0. I1 is again equal 0.04. If you simplify this one, we're gonna have here 600 I2 plus 100 I3 will be equal 8 plus 8, which is equal 16. This is our next equation. I will call this one is here 4 or 5. Okay, so we're gonna use this one here. We're gonna rewrite this one again here, new one. That will be here negative 500 0.04 minus 100 I2 plus 1000 I3 plus 200 0.04 minus I3 will be equal 0. If you simplify this one, I believe you're gonna have minus 100 I2 plus 800 I3 will be equal, this is 20 negative, this is here will be here 8, so it will be negative minus 8, which is equal 12 right there. So basically we have two equations. I can write the equation right there here one more time here this way: 600 100 negative 100 800 matrix I2 I3 will be equal here 16 and 12. So we need to solve this one here. I'm gonna use the MATLAB to find out the value basically. Okay, next slide. Actually, if you go to next slide here, next slide we have same equations right there. This is the equation 2. This is the first equation right there. So I2 comes 23.7 milliampere. I3 comes 18 milliampere. So I0 was equal I1 minus I3. That's why for the minus 18, this give you 22 milliampere. Again, this is for only one sources. When we have second time, let me go to back slide again one more time here. This case, we're gonna take out this one here. They're gonna put back the original V right there. When we take out the current source, will be open circuit. So we're gonna have this case two mesh. So let me go next slide here. So that's why it's open right there. You can see open right, this area here is open right there. Okay, so we can write two mesh equation, one and this one here. When you write first one here, I call I4 and I5. I didn't want to call same name. I4 here will be equal 100 plus 200 plus 300, which is equal 600 I4 minus 100 I5. And also this one is coming here as negative entrance, so you have negative 200 I0 equals 0 right there. Second one, if you write second one is here I4 effect right there on a negative 100, that's why we have negative 100 I4 plus 500 plus 100 plus 400 will be 1000 plus 1000 I5, because entering the positive side right there you're gonna have positive 200 I0 double prime. And also we have source right there, that's why we have negative 10 right there. So in this case, I0 double prime is equal negative I5. Okay, let me leave it in room right there. I can show it to you what's happening right there. So first equation will be here 600 I4 minus 100 I5 minus 200 minus I5 equal 0. This one comes here 600 I4 minus or minus gonna be here plus, so it's a plus 100 I5 equals 0. This is one of the our equation. I'm gonna call this one as 10 right there. Okay, so using 8 using 8 using 8 we have here negative 100 I4 plus 1000 I5 plus 200 negative I5 will be negative 10 equals 0. This will give us a negative 100 I4 plus 800 I5, because negative 200 gone right there, will be equal 10. This is equation 11. So our matrix will be like this here. If I have enough room right there, I will say 600, 100, negative 100, negative 100 right there. We have 800 right there. I4, I5 will be equal 0 and 10 right there. From here, we can find out the I4 and I5 value, then we can find I0 double prime. That is on the next slide. Actually, we have those equation right there, number 1, number 2 here. So in this case, I4 comes negative 2 milliampere, I5 comes 12.2 milliampere. So I0 prime will be equal negative 12.2 milliampere. So when you find I0 will be I0 prime and I0 double prime, which is come here 9.8 milliampere. So we can solve this way too also, if there is a independent sources. Next part of this one here, a source transformation. This is basically a simplify the circuit. If the source transformation basically like this here, so we can replace the voltage source with series resistor by current source and with parallel resistor. So basically, if you have a voltage source and serial resistor here, we can represent that one with current source and parallel resistor. R is here, is same R right there. The current here, IS will be equal, basically, IS will be equal VS divided by R. The other way, even you can go the other way, if you can go this way too also. If you have a current source with parallel resistor, you can transform that one as voltage source and serial resistor. In this case, voltage source will be equal here IS times R. You can do same thing for independent sources too also. You have a voltage source, serial resistor here. We can make dependent current source with the parallel resistor. Same idea here. Let's give example. Here the one example here. This information we can solve again using node analysis or mesh. We can solve it. The question is asking to find out the V0 right there. Okay. We're gonna use the source transformation. I look at this way here. I have a current source right there. I have a parallel resistor. If I change this one to voltage source right there, with the serial resistor, I'm gonna have two serial resistor right there. That's why we changed this one here. So 550 milliampere times 400 give you 20 volts. That's why we have 20 volts right there. This is negative here. This is positive here. Negative, positive. The reason negative, positive because current goes to this way here. So resistor will be serial right there. And when I look at this one here, we can combine this two resistor together. We are trying to not touch the 800 ohms. We're gonna try to leave that one alone. So we can combine this one together. So in this case, will be 400 plus 200 will be 600. Okay. So our circuit can be like this here. We have a voltage source, negative and positive here, and we have a resistor here, and we have a resistor right there, and we have a resistor right there, and we have one voltage source right there. So this one is 400, this, no, 600 total. This will be here 300, this will be here 800. This source is 20 volts, this is 12 volts. Even you can go forward, you can convert this one to current source and parallel resistor. You can convert this one to current source and also parallel resistor. So we can have like this here. So so easily you can combine 20 divided by 600 right there. This is 600, this is 800, this is 300, and this is 12 divided by 300. The next step, actually let me show it to you here. Next step, we can combine this one and this one here together, because this resistor parallel to this one here, this current parallel to, you can add them together. So we can have one current source, one resistor, and also this resistor right there. Let me see, I can have that on the next slide here. So that's why we do right there. You see right there, we have current source, parallel resistor, this one here, and this one here. So we can combine this one and this one together here. So the current source are subtract because different direction. So 33.3 milliampere 40, and this is 40. That's why you're gonna have difference right there, 6.7 milliampere. 600 parallel to 300 give you 200. That is right there. That's the one we have right now. So next step here, you can actually convert this one if you want voltage source and serial parallel. Then you can find voltage division, or in this case we don't have to simplify anymore. We can find the current right there, then voltage right there easily too also. What is the current right there? Basically current right there is equal, easily we can write that one is here. If I'm gonna call this one is I0, I0 will be equal 200 divided by 600 plus, no, 800 plus 200 times 6.7 milliampere. Oh, it's right there. We got this one here. So we can find current times resistor value give you V0. This is the way we can simplify. Let me see here. This is exercise problem. I want you guys do this one before the class. Let me see any problem in the class. We can talk about this one. Okay, this is the end of the section.